Pat McDevitt, responsible for global engineering at Tele. And as Brady said, this summer we had a pretty exciting event for us. We were acquired by TomTom, based up in the Netherlands. And while that was a very important event for us internally, and it was something, it was exciting because it was our largest customer, and we knew that life would change being owned by a consumer electronics company. One of the most important innovations for us with TomTom and with a lot of our customers had actually started about a year before that. And that was as we started to look at, it's sort of maybe a trite way to say it, but the power of the web, but more importantly, the power of community. Would it be possible for us to actually capture input coming from the end user, from the community of people who were using our maps and using these devices to actually improve the quality of the map? So what I want to talk about is how Teleatlas, with TomTom, with some of our other partners, is now collecting, consolidating, and using that community feedback, putting it into our maps and pushing that back out into the market. In fact, this month, October of 2008, this deal just closed in July, is our first release of products that have real community input already in it. It's a small number at this point, about 50, 60,000 corrections based on community input. But we expect that number to be going up a lot as the pipeline between the two companies expands. What I wanted to do, though, was start by taking a small look back at a picture that I know you're familiar with, some early discussions a few years ago about what is Web 2.0 and what are some of the thinking that is underlying this. And a few of the boxes on this, or a few of the bubbles on this, I boxed because they're quite relevant to what we're doing. The long tail, trust your users. Software that gets better the more people use it. Emergent, user behavior is not predetermined. Hackability. Well, how are these concepts relevant to the map-making business, the digital map-making business and navigation? Well, in ways that might surprise you. Trust your drivers. Trust your motorists. Trust the people who are out there using your product, encountering reality, and seeing changes. The long tail, I talked about this at the conference that was held in San Francisco at Where 2.0. You know, when you change the economics of production and delivery, as discussed in the long tail, suddenly you have new content. While Teleatlas isn't in the business of telling you where the best sushi in Berlin is, somebody is doing that, right? There's a huge amount of new content, geographic content that is now available. Routing behavior not predetermined. The best way for you to get across town or to go on your holiday is going to be different depending on the day of the week and even the time of day. So the routing is going to change depending on not only where you're going, but when you're going. Hackability. You can now record your voice or the voice of your kids to be providing the voice guidance in a TomTom unit. Wikimap, the OpenStreetMap project, allowing people really a community-based mapping project. And finally, this idea that maps that get better the more people use them. Probably the most difficult, challenging, but fun part of our business isn't putting information into the core database. It's not rendering the map. It's not creating the product. The most interesting, fun, and hard part of what we do is detecting changes in the real world, all right? Unfortunately, no one has an obligation to tell us that there's a new highway ramp or that a community has changed its addressing. The small town I grew up in Pelham, New Hampshire, this summer changed a huge number of its streets and addresses to make sure that emergency vehicles could correctly get to the right locations. So new addresses, new highway ramps, new residential neighborhoods. Those are things that we need to detect in hundreds of countries around the world every day. And that's the part of our business that is most changing by tapping into community input. So let me contrast that with how we've done this historically. Typically, we use and have used for years and years imagery. Imagery has become much more available, has become much better, better resolution, more accessible, and much less expensive. And we can do change detection with something like high-resolution aerial imagery to give us an idea that there's new geometry. We can also use it for the attributes that we bake into our maps, right? So you can sometimes get information on potentially lane information or direction of travel. Or in a case like this, you can not only see that there's a new roundabout going in here, but probably a new office park. Maybe there's some new points of interest, almost surely some new addresses. So you can use imagery as an excellent source of prompting change detection. Another way that we do change detection is with a lot of research, literally crawling the web. It's not how we started, obviously. 30 years ago, that wasn't the option. But literally crawling the web, doing research, municipal governments, any place that's funding some kind of street expansion, address changes. Interestingly, in more and more countries, going to the environmental agencies is one of the best places to do change detection, because if it's a publicly funded works, they need to do an environmental impact statement first. One nice thing about the changes that we're looking for is they're not like weather events. They're not a surprise, right? People don't suddenly discover a new highway or motorway ramp. They don't suddenly discover that they live in a new address. These are highly planned events, but they're non-uniform. They happen in a lumpy sort of way. So you've got places of high degree of growth, high degree of development. So we do this kind of research manually. We do this research crawling the web with imagery. We also use the power of local governments, which is obviously strong, but their interest in their local infrastructure is also quite strong. So local governments have information about their tax base, about the kinds of properties that are there, the addresses, et cetera. So that combination of imagery, of research, of local government has traditionally been what we've used. But about 18 months or so ago, we started to talk very openly with some of our partners, with Google, with TomTom, about how could we use feedback that they were getting and stream that directly into Tele Atlas to make updates to our maps. So at that time, we introduced a service that we call Map Insight. This is the front end that we've designed, but most of our partners don't use this. Most of our partners use the API that allows them to connect to this. We don't want to own the customer relationship, so we're very happy for our partners to be the ones who have the external view on this. So it's purely an API. Our customers use this to send us feedback, and what's most important internally from a Tele Atlas view, from a production, from a map creation view, is that this feedback is very discrete and it's highly actionable, right? So it's interesting for someone to say, hey, Los Angeles is different, but I can't do anything with that information. But if we make the device, if we make the end user community experience in such a way that they can give me feedback that's actionable, I can make a very high volume of edits to our database and push that back out into the community. It's a very, very different approach for how a company like ours looks at making maps. 15, 20 years ago, we were mostly staffed by cartographers, people who had surveying expertise, who really knew how to make a very high quality center line for a road. Now we're looking at taking very high volumes of community input, consolidating that, comparing it, statistically analyzing it, and making updates to those products. Also imagine if you had the ability to collect anonymous information about the locations of those devices. And by consolidating that anonymous information to actually affect what we're calling anonymous collaboration, so that you can see what are the preferences that people have for driving through downtown Berlin at 2 o'clock in the morning on a Friday versus 2 o'clock in the afternoon on a Saturday? Where do those trace files take you? What information can you glean about actual speeds and preferences for driving? We're not going to abandon our traditional methods of doing this, but what this is really about is blending the very best of community input with our traditional methods of surveying, of using aerial imagery, mobile mapping vans, and community input to build the very best and freshest map possible. Thanks very much.